Hi, welcome back to day two of the Machine Learning Faculty Development Program, organized by Squad Infotech in association with Nagendas Khandwala College. I welcome all the participants, those who are present here yesterday, and those who will be present here today. I hope all of you have filled up the feedback form, which we have shared yesterday in your WhatsApp group, and you have also attended the quiz. Make sure you are doing that. We have given time till today at till 3 o'clock, and we are giving you 30 more minutes. The link will be live for 30 more minutes. At 3:30 we will be closing the feedback link for yesterday and the quiz link as well. So let me introduce or anybody who is new here today. For all of you, let me introduce the faculty. Her name is Nidhi Grover, and she has been taking sessions since last 5+ years. She has ample of experience into various subjects: uh, Python, machine learning, data science, PHP development, full stack development, so and so many experiences into the technical field. And let me request Madam to please take over the charge, and if possible you can solve the queries of students if in case they have any. And all the participants, those who are live, please drop your questions on the chat box. You are live through our YouTube channel, so in the comment section put your questions. Okay, whenever it is possible, we will be looking at the question and we will answer the questions. Thank you so much. Over to you, Nidhi madam.
A very warm welcome to everyone. Good afternoon, all of you. Welcome back to session 2, day 2, new day, but the same topic. We are going to discuss the same topic, that is machine learning with related paradigms of data science and data analytics. We'll be going through the sphere of all these three just to get an insight what can we do with all these paradigms, how to develop our career in these, and what should we study, how to study, where to study, and what to study. Basically, these are some of the crux questions that everybody is confused in. Like if I want to go in the field of machine learning, or say I want to go in the field of data analytics, first of all, what are these? Then what should I study, and what should it exactly do? What should I learn to get proficient in these fields? So these are some of the crux questions that arise in everyone's mind whenever we are going to decide our careers. Okay, as far as students are concerned, whenever I interact with students, I get this kind of questions from them, that ma'am, what should we do? What career should we set up in these kind of fields? So my purpose of this webinar in these 3 days, I'm just wanting to give you an insight and in-depth knowledge of this particular thing, that yes, you can build up your career in machine learning and data science, and what are these fields about. Okay, so my purpose would be this, that to make you clear and sound in all these three paradigms, and to give you a direction. Okay, so you can go through that direction and you can set up your career. Okay, so my purpose would be this. So let me just give you a brief description of what we studied yesterday, what we went through yesterday. We discussed what is data science. We discussed it as a complete science of data. That means we are going to fetch up the data, we are going to pre-process it, we are going to clean the data, and then we are going to apply the algorithms to that fetched data, through which we are going to take out or dig out the important information, the interesting patterns. Okay, that patterns or that knowledge we can use for our future decision making. So that really frames out or sums up what data science is all about. Then we just brought about the paradigm of machine learning with help of artificial intelligence and data science. We just talked about that artificial intelligence is the complete science of building up intelligent machines. Okay, it's the hardcore coding programming through which we can develop machines. I gave you several examples of robotics and related fields. And then came the subpart or the subdomain of artificial intelligence, that is machine learning. Machine learning shares the domain with both artificial intelligence as well as data science, because machine learning is the technology, the science of data, with the help of which it is trying to make the machines learn. It is taking the input data and then it is utilizing that data for the machine so that machine can dig out patterns from it and learn itself. Okay, and through that knowledge that the machine learns, that knowledge can be used to take decisions for the new data, that is the test data. So ultimate task is the decision making for the upcoming test data. Okay, so there were three parts: the training data, the model, the framework, the solution that we are designing, and nextly or the lastly, it was the test data through which we are actually going into the process of decision making for the future. Okay, so this was the whole summary of what we learned in data science and machine learning. Then we talked about the types of learnings in machine learning. The last topic where we stopped was this only. We were talking about three types of learnings. We were talking about supervised learning, unsupervised learning, and reinforcement learning. So we just talked about the supervised learning, where you have, you have the ultimate goal. You know what could be the outcome. You have the labels with you. Okay, if you want to you want to train your data, you want to make decisions for certain categories, then at least you have the idea of what the output is going to be, what the outcome is going to be. So accordingly you can train your model, you can train your data into that model and then get the outcome of it. Fine. But in unsupervised learning, the outcome was unknown. You had some raw data, and then you had to check out the similarity index in that raw data. And according to that similarity index, you were trying to group the data into certain collections, into certain categories. So that kind of groups or collections were known as clusters. So basically in supervised learning, the purpose is to categorize or classify data. So the term that we will be repeatedly using in supervised learning is all about classification. And the purpose of unsupervised learning is to group the data based, because you don't have any outcome based now. You don't know what to categorize, how to categorize. So you are just trying to group it. First of all, you are just trying to segregate the data into different clusters, and then you are going to think, okay, what should I do with these clusters, what knowledge they are giving. So that is the separate issue, that is the secondary issue. The primary issue with the data set that you are being given for unsupervised learning is to first of all process that data and to think about, okay, what are going to be the similarity indexes, what they share in common, what they have in common. So according to the similarity factors that you visualize, that you analyze through them, according to that you are going to group them into clusters. So here repeatedly in unsupervised learning we are going to use the term clustering. Right? We will see classification and clustering in details, and I'll just try to give you a sum up of what are these technologies and what algorithms you may be using. Because in the 3 days we cannot do the entire machine learning. I cannot teach you the entire algorithms. In fact, we cannot even go through the details or the entire algorithm set. So what I have planned is that we are going to have a glimpse of each and every part of machine learning. We are going through types of learnings. We'll see one or two algorithms of the same. We'll try to imbibe something with Python, what frameworks we have to use. We'll go through the number of tools that are available to study machine learning. So we will just see the glimpse from the outer sphere. We will just have a brief idea of what the machine learning is all about, so that after this webinar you can decide yourself that you are interested in this particular domain and you want to study it further. So you will be having that direction that, okay, these are the points along which I have to study. So my purpose through this webinar would be to give you the glimpse of the complete domain. Okay, what the machine learning is all about and how you can go about this. And the first type of learning that we talked about was the reinforcement learning, where you are actually training your machine to learn from its own mistakes. The machine tends to make mistakes. it will make mistakes, and you are setting two parameters. You are either giving the rewards for the successful or good decisions, and you are giving penalty for the wrong decisions. So accordingly, you are training your machine to learn. As soon as the machine learns and keeps on making mistakes and keeps on earning rewards or penalties, then what happens is eventually your machine improves itself. Okay, if it improves itself, that means your algorithm, the model that you have designed, is going in a positive direction. So according to that number of positive rewards that you are giving, rewards could be in form of points. Okay, the machine is calculating in form of points. Okay, I did make this decision, and this decision tends to be right, so I got 5 points for this. So rewards is +5. The counter is incrementing. So the algorithm is keeping a check on the counter. Now what is happening? The number of positive points, more number of positive rewards, makes your machine to improve itself. So that means the output is an improved machine. And on the other hand, if the penalty is more, that means then you have to either change the parameters, or you may have to, in extreme cases, you may have to change the model itself. You have to may change the way, the flow of working itself. It may happen, it may not. So there is no, there is no, I can say, definite part that yes, keeping the algorithm same and changing the parameters will serve the purpose. It will improve your machine. No, that's not the fixed part. Okay, in extreme cases, you can, if the solution is not working with changing the parameters and activation functions and throughput values, then what you can do is, then you can change the algorithm itself, because machine learning is giving you ample lot of algorithms. So every algorithm has its own pros and cons, and accordingly you can use the algorithm to solve the task of your problem. So that ways you can choose any of this. So, and yes, one question more arises in our minds when we talk about these learnings. It means that whether we are using supervised, unsupervised, or reinforcement, what is the best scenario to use them? Can we pick and choose among the three of them, or what are the definite scenarios in which I should choose one particular learning? So dear friends, let me make it very clear. It strictly depends upon the situation you are dealing with. Okay, it depends upon the task that you are dealing with. If you are dealing with a known situation, if you are dealing with a known task which has been implemented earlier, like I give you an example. Okay, suppose we all are from IT field. Okay, we have developed some other softwares, and we have developed some programs. So if I have a program which is known to me earlier, if I have a problem which is similar to the ones that I know earlier, okay, then I can use those things that I did in the earlier versions of my software. I could use those concepts, those code parts, those snippets with me. Okay, but if I know that thing, if I know what the outcome could be, or what kind of software could be used, and what usabilities that particular application could have, then I can use that same the earlier versions of my product, of my software, into my current version. But what happens is, when I don't have any idea, the things become tricky. When I have something new to develop, new requirements, then I'm hitting and trying, and then I'm thinking, okay, what it could be like. Can I use that thing with this? I'm just hitting and trying. I'm just checking out. Okay, this thing may be similar to that particular thing that I did some time ago, because this is new to me. So I cannot definitely or precisely say, okay, fine, this problem is similar, completely similar to that particular problem. This is of that category. No. So this depends on the type of problem you are dealing with. Sometimes you are dealing with the known set of problems. Sometimes you are dealing with unknown set of problems. Those problems which you didn't encounter any time before. So if you are dealing with some known outcomes, known problems, then you must go for supervised learning. You must go for classification type of problems. And if you are completely unknown, you have a different set of outcomes, and then you have to just go through that in details, and the data has to be gone through in details, then you must go for unsupervised learning. Then you must go for clustering part of problem. And if you are just making yourself an out of box thing, and you are just and you now self-dependent, atmanirbhar. Okay, so if you want that machine to be self-dependent, then you have to go for reinforcement learning. Okay, you don't have to jot down anything for that. You don't have to program it for anything. You have to just set some thresholds, some points that your machine should be learning and taking decisions. So that would be reinforcement learning. You must reinforce your machine again and again. So it is going to be the most tricky, or the completely different kind of a scenario that you may be dealing with. So although this was a complete summary of what we did yesterday, so I think now it's time to just move ahead with our session. So I'll be sharing with you my content. Let it be. Okay, guys. So today we are going to deal with certain topics. We are going to explore the machine learning paradigm more, and we are going to see it from the angle of data science and data analytics as well. We will also talk about different machine learning algorithms that are available for us and in what scenarios we are going to use those algorithms. Plus, if the time permits us, we will definitely see the Python related part with it. Okay, so we'll see some practical aspects also. We'll talk about the applications also as far as machine learning is concerned. So we are going to see all these subtopics in today's session. Okay. So let us dive into machine learning. So yesterday, what we did was types of machine learning. This is where we stopped. So as I gave you a brief overview of this also, that we had talked about supervised, unsupervised, and reinforcement learning as well. So I just gave you a brief up of all these types of learnings. So, okay. Now, today I introduced you to another, new buzzword, new term, okay, that you continuously see in the world of, data technologies. So these two terms which people usually confuse, okay. So I just want to clarify these two terms, these particular two terms. Whenever you go for an interview in the field of data technologies, okay, people usually ask, okay, what is your data analysis and how it is different from data analytics? Okay, these are two widely used terms which seem to us that they can be used, for each other, okay, interchanged with each other, but no, that is not true. Data analysis and data analytics is purely different from each other. They both share different domains and they have different usabilities. So if I talk about data analysis, then you can yourself think, okay, I have to analyze something. Okay, I want to analyze the sales of products of my company. Suppose I have the company of my company is making shampoo based products. Okay, so I want to see the sales of different varieties of shampoos, these products that my company is selling under different locations, in different locations. So what I'm going to use, what I'm going to do, I'm going to analyze the sales that our company has made in past. It could be 1 month, it could be 6 monthly report, it could be 1 year report, or it could be, it could be 5 years or completely 5 years report. It could be anything. The analysis part means that you are trying to analyze the data that was made in history. That means that event has occurred in past. Analysis is done on the things that are already happened. They are happened in past. And what we are using for this analysis for? We are using this analysis to explain, okay, how did this happen? Okay, why did this happen? What happened? So we are trying to explain three questions out of our analysis. We are trying to explain what happened, why happened, and how happened, and how. So we are going to answer these three questions: what, why, and how. So these three questions will revolve around us when we are trying to analyze things. I gave you an example that I want to analyze the sales of my company, the products, the shampoo products that my company is selling. So I want to analyze the sales. So what I'm going to do, I'm going to analyze the sales of say 6 months, past 6 months. So from say November 2019 to March 2020. I want to see the sales of these 6 months. So what I'll do in analysis, I'll see what happened to the sales. Were they decreasing or were they increasing under certain locations? Okay, why it happened? Okay, if it was increasing, why it was increasing? If it was decreasing, why it was decreasing? What was happening? What was the reason? I wanted to know what was the reason. Then third thing, how it happened. Okay, what actually happened behind the scenes that made the sales of my products to increase or to decrease? So going behind the scenes is the part of analysis. Whenever we analyze something, we are trying to get behind the scenes. Fine. We are trying to analyze what, why, and how of that event. So according to that, the analysis of the data analysis part branches off to two domains. Okay, one domain says qualitative analysis, another domain says quantitative analysis. So when we are talking about qualitative analysis, so basically we are trying to analyze the data which is not numerical in format. Okay, it is more subjective. It is more based on, verbal. It is more based on what your intentions were, what you analyzed, okay, through the scene, through the scenarios, what you heard, what description you got, what you explored out of it. So qualitative analysis is more concerned with the analysis of data that you cannot quantify in numeric forms. You cannot quantify what you assumed earlier and what you got. You cannot quantify, okay, the descriptions that you got. So it is more or less descriptive in nature, subjective in nature. It is not statistical based. It is non-statistical, and it is exploratory in nature. So the main target, the main purpose here is to explore. It is to dive in to that particular scenario and to see what qualitative indexes need to be analyzed. So we are just trying to analyze the qualitative indexes that you cannot quantify. Okay, so now according to that, we come to another domain, that is quantitative analysis. So quantitative analysis is associated with numerical analysis. So now here we are into the world of numbers. So now you are analyzing on the basis of numbers. Okay, if I'm seeing the 6 monthly report, then what first thing I'll go through? I'll just go through the number of products that my company sold. I'll go through the revenue that was generated. I'll go through the profit that my company made or the loss that was incurred. So in a way, it is not subjective. It is more objective. It is more objective based, because whenever you are going for a business, okay, with a business mindset, any businessman would think of in three terms: more sales, less losses, more profits. So these three terms are in the minds of each and every businessman, that whatever he is selling or whatever he is dealing with should be more. He should be dealing with more sales or more customers. So that part, whomsoever the businessman is dealing with, he wants to reach to more. Fine. So less losses. That means you don't want your sales to go down and then you are incurring losses. So that you don't want. And on the same part, you are trying to maximize your profits. So your objectives are very clear. You want to reach to more sales and more audience or more customers, and you want to incur less losses, and you want to earn more profits. So that kind of approach, when you are analyzing with that approach your sales or your company data sets, then you are going through quantitative analysis. You are dealing with quantitative analysis. Okay, so what we learned from analysis part is that we do analysis on historical data. We are dealing with the past events, and we are trying to explain either qualitatively or quantitatively. We are trying to explain three things: what, why, and how. So these three questions we are trying to analyze out of our data. Now we come to the buzzword. Okay, the analysis part is okay. We all do analysis. But say into analysis, then what is analytics? Why it is so special? Because I am telling you this, that data analytics is a buzzword. People are going for analytics. They are developing their careers as analysts. So analysts, they if you are directly going for the job profile of data scientist or data analyst, then you must be very well versed with data analytics. So anyways, let us just go about it in deep. So data analytics deals with future. So completely contrasting statements between analysis and analytics. Analysis was done on past events. It dealt with history, and analytics refers to future instead of explaining past events. So you are not explaining past events, okay, and you are just referring to the future events. You are dealing with the future events now. You are trying to predict future. You are trying to make decisions for your future. I hope guys you are getting what we are learning. You have got a brief idea of analysis. If you have if you have learned it clearly, if you have got it clearly, please type yes on your YouTube. Okay, that will make the session more interactive. I'll try to make it more interactive. I'll keep on interacting with you people. If you are understanding, if there is no problem and everything is going fine, then please type yes in YouTube chat box. Okay, fine. Let me get back to what we were studying. Okay, so we were dealing with analytics, and analytics refers to the future instead of explaining past events. So it explores more future, future options with us. So analytics is the application of logical and computational reasoning to the component parts obtained in analysis. So now what we learned from analysis, what was what, why, and how. Now, why we did this? Okay, why we got the analysis? Why we went through the analysis part? There has to be some purpose. We did analysis for some purpose. So the purpose of analysis is analytics. Fine. Just remember this. The purpose of analysis is to go through analytics. So what you do is that you analyze for a particular reason, and that reason is to get the know-how for your future. What predictions you can make for your future, what you should keep in mind for your future. So that points you go through in analysis, and you predict them for your future events. So analytics also branches to two different domains. As it was in analysis, now analytics also goes through two domains. It is qualitative analytics and it is quantitative analytics. Now, qualitative analytics is using intuition or experience in conjunction with the analysis. So what you analyzed is one part. Okay, you made analysis on historical events, on the previous sales values. But now you have to promote your products in future. We are continuing with the same example, like I gave you in analysis, that I was trying to analyze, okay, the shampoo based products of my company. So I analyzed the sales of those products. Now, using those analysis, if I am, incorporating my intuition also, okay, fine. In next 2 months, the sales may increase if I go through the promotion from some celebrity. Okay, if I hire some celebrity for doing this, if I hire say Alia Bhatt for promoting my products, then my sales will increase. This is my intuition. Okay. Now this intuition must be based on my experiences. Okay, I saw, I may have heard, or I may have seen this, that she's a popular celebrity, and if she's going to advertise for our products, that our the brand value will totally be very confident, and people are going to buy this more. So it may happen. So my decisions would be based on either the history or the analysis that I did, or it could be on my intuition, or it could be my experiences also that are forcing me to take that particular decision. So that kind of values, okay, so that kind of analytics means qualitative analytics. Now going to the next part, that is quantitative analytics. So data analytics is, if we are talking about qualitative analytics, it is a businessman's personal choice. If he is wanting to incorporate qualitative analytics, it's okay. But they hire people for data scientists, as to be data analysts, to be data scientists. So that kind of job profiles have some purpose. So that purpose is dealing with the quantitative analytics. Okay. अगर अगर ये जॉब्स भी हैं, अगर इन लोगों को भी हम हायर कर रहे हैं, so that means कि कुछ पर्पस तो होगा इन लोगों का. So there, here is where quantitative analytics comes in. So this is from the algorithm. So now you are applying your scientific knowledge, the technicals part, the technology that you are using. So you are applying formulas and algorithms to the numbers you have got from your analysis. So now you are just permutating and combinations you are doing. Okay, fine, my sales are going down because of these reasons. My intuition is to do this, but my number says that no, you should go this way. Okay, you should increase more. You have to invest more in suppose in a particular area, say Kochi. It came into my mind randomly, so I'm taking the example of Kochi. So in Kochi, the product sales are less for my company, for example. So if I have got it, my intuition says, okay, continue with this approach. But the numbers, the figures say that no, the sales are going really down, and I have to be ahead of competition. I have to do more promotion. I have to, go with them, with some celebrity or some local celebrity out there. The people, adore somebody, some celebrity, and I should go with him. Okay, I should associate him with my product, and then the sales will increase. So all this data can be got through quantitative analytics. So as in whole, the business setup uses both qualitative analytics and quantitative analytics. So what we have jotted down till now is that data analysis is done on historical events and analytics is predicting future. Okay, you are using analysis and you are trying to predict future for your company, for your products. So that was the summary, the sum up about analysis and analytics. I hope you all have got some idea of what analytics is going to be. So analytics is a broader domain. If I say it's a broader domain, it's going to contain everything, because analytics is dealing directly with business. I am totally giving you the examples of business domain. That means analytics is going to work with business. So when it is going to work with business, analytics will use data science also, because data scientists are there to give you analytics quantitatively. So data analytics would be using, data sciences also. It is going to use artificial intelligence also. It is going to use machine learning also. Everything it is going to use, and it is going to bring about some patterns, some points that the company can use, for increasing its sales, for reaching to more customers, and improving its brand value. The most important task that any company, any business firm would go with. Okay. So applying data analytics to business, if I take this, that we need to apply data analytics to our business, then what type of analytics we'll be having? We'll be having 4 types of analytics with us. We'll be having descriptive analysis. Descriptive means you are just trying to describe, okay, what's happening with my business. What analysis are showing me, I'm just describing that. I'm just seeing that, okay, what's happening with my business. It is more comprehensive. It is more theoretical. It's it's giving you accurate data. You can see the current data. Okay, what's happening in your company right now, what's happening to your products, where they are selling more and where they are selling less. So you can work with live data. Okay, then nextly you have effective visualization. Now that there comes the part of visualization, the plots that you are creating. Okay, you are trying to describe your sales through graphs and through figures and through presentations completely. Okay, that you see in movies, that all the board of directors are sitting and they are analyzing their businesses and they are seeing some graphs. Okay, this is the part of analytics that they are dealing with. Okay, in the BOD room, they are sitting and then they are making strategies for their business. So they are describing things and they are dealing with the descriptive part of data analytics, with the help of which they are seeing the live data, the current data. They are making predictions and they are using visualizations. Okay, like from past 5 years, our sales are moving in a graph form. They are seeing it in a graph form, and then they want to predict where from now 5 years hence they want to proceed to. So that proceeding can be described through live pictures, to some plots, through graphs. So that kind of descriptive analytics they are dealing with. Then here comes the diagnostic analytics also. And the diagnosis, we hear this word. This is a very crucial word right now in the going scenario. Diagnosis. Oof. The diagnosis means digging in. Now you are going into the reasons. Now you are going into the reason that, okay, why it is happening. This analysis was why happening this, what are the causes. Okay, I want to reach to the roots. That is why I say digging down or reaching to the roots. Okay, because you are trying to go from the superficial details to the down to the bottom neck of this, that why it is happening. So you are dealing with the causes. You are trying to isolate all confounding information. So you are trying to separate informations, and you are trying to analyze them, that okay, fine, if this happened, why this happened, why what was it happening. Then it is predictive analytics. We are dealing with predictive analytics. Okay, now here comes the predictions. We are already done with discussions. We are already done with the root cause diagnosis. Now what we are dealing with is prediction. Okay, what could happen in future if this was happening from past 5 years and the cause was this. Now, based on descriptive and diagnosis, that is what I'm trying to tell you. Based on descriptive and diagnostic analytics, now you are trying to predict what could happen in next 5 years. Okay, what you are going to deal with. Okay, what kind of scenarios you are going to deal with. I give you an example. Okay, that you will be able to relate in the current scenario. Okay, so based on past 6 month corona record, whatever is happening in the entire world. Okay, based on that, the news channels, the professionals and the people out there who are very experts, okay, and the doctors as well, they're trying to predict. Okay, they have first of all discussed among themselves. They had a lot of discussion with the politicians and our big ministers, doctors. Everybody was in discussion. Okay, what is happening, why it is happening. So it was all descriptions and diagnosis. They went to the root cause. They reached to a virus known as coronavirus. Now they are trying to make predictions. Okay, in this virus would be, we will be able to deal with this kind of virus in the next 1 year or 2 year, and this kind of vaccine may work for this kind of medicine may work for this. So after descriptions and diagnosis, we have reached to a prediction that this may work. We can try with this. Okay, in next 5-6 months, we may be able to curb this problem. We may be able to solve this problem out. So now predictive analysis is there. Predictive analytics, sorry, is there. Now you are trying to jolt out the points for future, what likely to happen. So business strategies have remained fairly concerned with this. Historical patterns are used to predict what may happen in the future, okay, using certain kind of algorithms. Now, whenever I take the term algorithms, now these algorithms could be nothing other than the machine learning algorithm. So they may use machine learning algorithms, okay, to make some decisions about what may happen in future. Decisions are automated using algorithms. So now you are trying to automate the decision making. So automation, whenever the term automation comes, you are directly onto the field of AI and ML. So you are directly dealing with your intelligent systems. Now, preemptive. Last one is the preemptive analytics. It suggests you what should be done. Okay. Now you have three things. You have descriptions, you have your diagnosis with you, you have predictions with you. What could be dealt with in future, what is there in future. Now the last term is what should I do if I know the future is going to be good sales, everything is good. Now I want that kind of future, that next 5 years my company should be brand number one. Or that what should be done, what other steps or the rolls out that should be done. So those recommended actions and strategies, they deal with in prescriptive analytics. Okay, so those you are dealing with in prescriptive analytics. So you are applying advanced analytical knowledge and techniques to make recommendations. And in the diagram here, in the graph here, you can see okay, descriptive analytics is the smallest part, because you are just discussing, you are jotting down the points. And then comes the diagnostic analytics. It is much bigger because you are trying to find the root cause. Then it is predictive analytics. You are trying to find out what's likely to happen. And finally, it is prescriptive. Now you are trying to jot down the strategies. So it is, it is going from downwards to upwards. You are seeing more value. You are spending out more value. When I say value, you're spending out more value, and you are going through more complexity. So as you go to each and every level of diagnostics, each and every level of analytics, you are moving to more and more complicated part of analytics. So I hope you have realized what analytics is all about and how businesses use the analytics. So I try to give you examples real time. So I hope आपको समझ आया होगा सब लोगों को. If you have got the point, if you have understood, please yes, you have got the point. Okay. No, now uh, let us see how we can combine these two things. We can combine analysis and we can combine analytics together. So as we can just see in the diagram here, we can see we are using all four types of analytics and we are analyzing things. This is a continuous process. We are continuously using this process. This process is not one way, it is a cyclic process again. We are continuously using analysis and analytics, okay, for our help. So we first analyze, then we make, predictive analytics, then prescriptive analytics, and then we are also viewing diagnostic and descriptive analytics. So we are just seeing what happened. We had some information. If we start with the circle from downwards, we had some information. So what we started with was descriptive analytics. We jotted down the points for what is happening, then why did it happen, okay, diagnostic analytics. Then we did careful analysis of things. Then we went through predictive analytics, that what is likely to happen after analyzing things, after analyzing the complete information. I went through what is likely to happen, then what prescriptions should be given. Prescriptions, you can understand that word. So what prescriptions or what suggestions should be followed in future. So what should I do about it? So that way again I have information. Then again it is a circular process, okay. Fine, your company, the business uses both together, analysis and analytics, but yes, they both have their defined meanings. So I hope that would be clear to you. So this way we can use analysis and analytics together. Okay, so now the next buzzword of data world is business intelligence. Now, after all, we are dealing with data sciences, we are dealing with machine learning, we are dealing with data analytics, we are dealing with all such terms. So here it is the right time to introduce you to the term BI, business intelligence. Okay, whenever if you are dealing with corporates and if you have any knowledge about corporate sector, then they have special people hired as BIS, okay, business intelligence specialist, or BIE, business intelligence expert. So these are very important people for any kind of business. Okay, big companies are investing a lot in their business intelligence peoples. So what is this and why they are doing this? Okay, so BI refers to the technologies, the applications, the practices for collection, integration, analysis, and presentation of business information. So business people, they may or may not be very sound in technical part. So they hire people who can understand what the customers require, and then these are the middleman. These people are the middleman who can understand what the business require, what the customer require, and what technical part should be incorporated for fulfilling that task of the customer. So these business intelligence people, or I say this particular field, refers to the application and practices which involves collection and integration and analysis of business information. Okay, everything is being done by business intelligence expert, or business analyst is also a term that will pop up with this this particular domain. So the purpose of BI is to support better decision making of the business. So ultimately, business intelligence is meant to support decision making process. Okay, you might have heard the term decision support systems, DSS systems. So data analytics, whether you are using data analytics and whether you are incorporating data science or machine learning with analytics, you are dealing with ultimate purpose of decision making. So these are all technologies which are helping in decision support systems, because ultimate, the purpose of the manager, the management people, is to make good decisions for future. So all this tamjam, all this, all this thing, everything what we are studying, all this particular technology is meant for decision supporting. Fine. BI systems provide historical, current, predictive views of business operations, most often using data that has been gathered in a warehouse. Okay, so what you are trying to do is you are trying to incorporate your operational systems. You are trying to use data from your operational systems, and you are trying to store that in your data warehouses. Please remember one thing surely: whatever data your company is using, whatever whether it is using data of its sales, of the product basis, of the customer base, or maybe it's a Facebook live feeds or live posts, pictures and videos and everything of their customers, they are going to store their data in a server, in a complete group of servers, I would say. And that group of servers is nothing other than data warehouse. It is their warehouse of data, where they keep on storing their data in big, huge servers, and then they are processing those data, and they are utilizing data sciences, data mining, KDD process and data cleaning and everything, BI also. They are using that data to get out some important information out of that. So the tools basically provide interactive analysis, visualizations, and statistical data mining. So BI is related with this. You want to analyze your data, you want to get some visualizations out of it, and you want to incorporate some statistics for your data. So information is often gathered about other companies also in the same industry, which is known as benchmarking. So you are also, see, whenever you are in the business world, it's not enough to deal with your own data only. You must have a close eye on what your competitors are doing. Fine. So you must be dealing with competitors' data also, because it is not worth it if you are dealing with your own sphere. If you are dealing with your own production data, own marketing data, it is not going to serve any purpose unless until you just see out of the box. You just see out from your own house. You see what other people are making, what other people are going. Okay, then only then you can make correct decisions for your company. So BI is that intelligent part. Okay, you can see the term itself, business intelligence. Now you are trying to incorporate machine learning, you are trying to incorporate data science and data analytics into your business so that you can move ahead of your competitors. So that is the main purpose of business intelligence. Okay, so I think that you all have got some idea, some brief about what business intelligence is going to be all about. So this intelligence word is very important, because whenever the word intelligence comes around, you have to be very sure that okay, now it's time for AI, for ML, for data analytics, data sciences to to talk about. So I hope you all have got the idea of BI. Okay, keep on interacting, guys. If you have any doubts, okay, you can just type in, you can just chat in the YouTube channel. Okay, if you have understood, keep on writing yes. If you have any doubts, okay, you can just ask in the chat box. Okay, now it's really now the time to sum up the things. Okay, we have talked about data science, we have talked about machine learning in brief, we have talked about analysis, analytics, and now BI. Now it's time that we see them all together. Now it's time we see everything together. We see in one snapshot. So let me show you in one snapshot what these things are all about. Okay. Fine. So in this diagram, you can see all the things, okay, where everything falls in, where each and everything that we have learned so far, that we have seen so far, fits in. So now it's time to just see this diagram and analyze it. So you at the top, okay, at the outer sphere, you have the domain of business analytics. You are talking about the domain of business analytics. You are talking about qualitative analytics. Okay, you are talking about business case studies. You are taking the case studies of different domains. You are taking the case studies of your competitors also, okay, to move ahead of this competition. So you are dealing with these things. Fine. In this diagram, if you visualize on the very first visual, you can just see a black line, okay, a dotted line, which is dividing this diagram into two parts, or rather I would say three parts. This line itself is a very important feature. So this line is dividing the complete scenario into three components: the past component, the present component, and the future component. So this line actually gives you an idea how and where to use each and every technology. Now you are learning so many technologies altogether, but where to use this particular technology, in which scenario you have to use, that part is very important. So business analytics, qualitative analytics, business studies, okay, these are the in the domain of business, but they are dealt with in separate times. Okay, in business, case studies are the past or the things that have happened in past, and you are just analyzing those case studies. So this is a part of analysis that you are doing. Preliminary data report is the data report that you are fetching from your own company. You are getting the production reports, you are getting some data sale and so on. Okay, now you are using the business case studies, preliminary data report to form a very important component, that is the business intelligence. Now you have used the case studies that you learned so far, you have used that report. Now what you are utilizing that for, you are trying to create visuals, you are trying to create dashboards, BI dashboards. Okay, Tableau and other softwares are being used for creating dashboards and for BI part. So anyways, that is a separate domain. So BI, business intelligence, deals with jotting down the points from the case studies and data reports, and then creating visuals out of it. Then you are creating presentations out of it. You are creating real-time dashboards out of it. You are presenting your business. Dashboard means you are presenting a framework of your business, that what is happening in my business currently, and for that you are seeing it in present. Business intelligence, if you see, it is dealing with both the scenarios. It is dealing with the past and it is relating to the present. That means that you are creating a dashboard framework. You are modeling the data that happened in past. You have compared that data with your competitors, and now you are presenting it in the form of dashboard to your managers. Okay, so you are doing it with the help of business intelligence, and you are doing it in the present scenario. Next, yeah, what you can do it now. Now you are going to the future component. You are dealing with the business intelligence in the present, and now you are moving forward to the future. Here is where these four different technologies that we have learned so far come into account. Here we are having business analytics. Here we are having data science. Here we are having data analytics and artificial intelligence as well. So business analytics, you are utilizing qualitative analytics along with that. You're utilizing for sales forecasting, for client retention, for fraud prevention. Okay, then you are utilizing data science in specific domains, like you are optimizing of drilling operations. If you are dealing with some of those businesses where you need to dig out something, dig out, like you are dealing with oil and petroleum and all these things. So drilling operations, you are optimizing those things, you are optimizing your processes. So data science, you can use the patterns. Okay, here we can go through with these operations. Then we have data analytics also. Data analytics deals with digital signal processing. So analytics is specifically used in these domains. These are some of the examples where you can use these particular technologies. So data analytics you can use with digital signal processing, like you can set up your routers, repeaters, and amplifiers in certain locations. Now how and where you should do this, where you should set up your network. Okay, that where question, that where you should set up the network, can all these things can be dealt with the help of analytics part. Okay, you have to describe, you have to predict, and then you have to go through the processes that you need to make for future. What kind of signal processing network should I make? So that kind of questions could be answered through data analytics. Anyways, then you have machine learning. Machine learning part deals with specific domains of speech recognition and image recognition. Okay, so if you see, machine learning is dealing with two things altogether. It is dealing with data science also. Sorry, machine learning, these two domains, speech recognition and image recognition, it is dealing with two things. It is dealing with machine learning also, and it is dealing with your data science also. So this is very clear. This, if you just see this, it is very clear that two things, speech recognition and image recognition, they need some data. Okay, they need to incorporate some algorithm into those data. If I say that I want to train my machine to recognize speech, if we say we are training Alexa kind of a machine. We are taking the example of Alexa here. So if we are taking the example of Alexa and I say that machine has to be trained to recognize what you say, it is trying to recognize your speech, it is trying to recognize your voice, it is needed to take commands, okay, voice commands, then it needs some data. We need data to train it. Okay, so that training, the modeling part is dealt with data science. You are pre-processing your data, you are giving some, pre-processed data, some good kind of data for training data to your machine, with the help of which the machine is learning. Okay, it is under supervised, it is guidance. Okay, so you are training your model, you have given good data with the help of data science approaches to your machine. Now machine learning algorithms comes here into account because you are using supervised voice. Now every voice does not recognize. If you say you are recognizing human voice, if a dog is barking, if a pet is barking, Alexa is not going to recognize that, because it is classifying that, okay, I have to recognize human voice. Now each and every voice should not be answered. So that kind of classification problem has to be there. That kind of, machine learning approach has to be there. So that is why speech recognition and image recognition has to be dealt with. Now, image recognition, suppose say we are developing a small application for kids, okay, small kids. Like I have seen some applications on Play Store. People have, made some applications for small kids where they have to recognize numbers, or they have to recognize characters, and they have to speak. Okay, the software will, receive their voice signals. Like suppose they are seeing the visual of character A. Okay, now the child has to say A. Okay, give an example. And apple, he can give some example also. So the software, the application is going to receive the voice signal. It is going to test that whether the answer is correct or not. The character, the alphabet shown is A or not. The number is that particular number 5 or not. So that kind of, these kind of applications are using both. They are using image recognition also, and they are using speech recognition also. Now, image recognition comes in when that application is requiring the kid to, write. If it is on screen, he has to write 5. If the image is 5, the kid has to write 5. Now the system will recognize these two images are similar or not. So that kind of real-time applications you can see. And obviously you can make these projects also. These kind of projects are very valid, and if you want to incorporate some ideas into these projects, they are going to be fantabulous projects for, real-time usage. These were some project ideas also, because some of them I have seen on Play Store. I keep on watching new projects, new softwares that are coming in the market. This gives you an idea of what technologies are being used. Okay, I just want to suggest you all also that keep a check on what kind of applications people are developing, because it will definitely give you an idea that, okay, where we are heading into future. What kind of, projects could be made, what out of the box approach people are using. So these kind of, things will help you develop your brain in technology field. Okay, anyways, lastly, we have artificial intelligence. Okay, we can make a complete robot out of it. We can use any of that robotic process to automate. Okay, if you are automating things, you are automating a bot, you are automating a machine, then that part is dealt with AI. Okay, fine. I have got some question. Okay, Shraddha Malvankar. Welcome, ma'am. Shraddha ji, आप पूछ रहे हैं, ma'am, can you repeat the BI? Okay, fine. So business intelligence, BI was all about business intelligence. I'm trying to show you the visual again. Business intelligence was dealing with, the business scenarios, how you can use the data science and the data part, okay, for improving your decision making in business. So it deals with your decision support systems in businesses. So I try to show you the visual once again. So this was all about business intelligence, where you are trying to incorporate the fields of data science and machine learning. You are trying to use the statistical tools and everything, okay, for making your business into an intelligent system. You are trying to, automate your business processes so that good and, positive decisions could be made, which can enhance your business. So if you want to, get more into business intelligence, then you must learn the dashboard softwares available. You can go through Tableau and everything. So that will give you, practical as knowledge on BI. So these people have to, learn all these technologies to be proficient business intelligent experts. BIE, BIS, these kind of posts do exist. Now, let me give you some information of this, that each and every company right now is having its own research and development departments. And those departments, like big players, if I talk about big companies, big players, all of them are trying to get proficient in, business and technical part. So they're combining together and they are having their fields of data sciences, machine learnings, and business intelligence and everything. So these are, very upcoming technologies. Okay, I have more questions. Suraj Mahendra Ramraj. Okay, he's saying, ma'am, I am in coding and AI. So how should I make it learn? This is what I'm not able to understand. Okay. Suraj, I didn't get your question exactly. What you are trying to, ask. Please reframe your question. Okay, till then, I take another question. Prajakta Dhumal, she is asking how BI exactly used in the organization. See, BI is, if you see the graphic on your screen, then the upper part of this graphic shows you business analytics. Now, business analytics and business intelligence, they work together. Okay, you are dealing with different kind of business case studies. You are dealing with data reports from your own business. And what business intelligence deals with is to, completely analyze all this and draft it into some visual so that your manager, so that the people can understand. Now, very basic question says that you can do it via presentations, you can do it via Word, but guys, let me make it to you very clear that data today is on a booming phase. Okay, you have held lots of data and nobody is so proficient that he can, analyze into each and every data manually and then create a presentation out of it. Okay, if I talk about a big company, say Google, okay, and it is visualizing, or it is trying to analyze its past 5 years data, what people searched, what strings were most popular. Okay, I hope you have heard about Google Trends. They give you comparisons of past, how many years of data. You can just type in, it gives you the comparison of the trends. Okay, what people searched for more, have to compare that two among two keywords, which was searched more. So that kind of trends it is giving you. So that kind of analysis is not done manually. It can be done only through some software. And those are business intelligence softwares that are being incorporated, and they are being used to create real-time dashboards. Okay, dashboards are again created through dashboards are again created through business intelligence software. Fine. Okay. Okay, Smitha is saying something. Smitha is saying, ma'am, earlier you were talking about classification and grouping, and now it will differentiate between them. Okay. Classification and grouping. Okay, we'll come back to that topic again. I'm just about to come to the machine learning part again. So I'll discuss it again in details there. So, okay, how we can add intelligence in solar energy? This is being asked by Adarsh. Okay. Adarsh, okay, if you want to, get into solar energy, if you want to add intelligence to the solar energy, they are already being used in, there are so many sensors that are being available. So you can use intelligence in that. You can add sensors, and those sensors can be used, to basically sense that solar radiation of so and so flow is there, and those sensors can be incorporated with some other solar energy panels, and they can be used in those systems where energy or electricity is being derived from them, or some IoT based systems. Okay, sensor based systems, like there are some sensor based systems which are recognizing sun rays, and according to that they are recognizing that daylight is there, so they are dimming the tubes, and that they are saving the energy by dimming the tubes, by recognizing the the energy part of the solar energy that they are receiving. So there are some of the applications that are being used. Okay, fine. Okay, fine. Okay, let's go ahead with this. Okay, I have put in a case study. We have discussed a lot of case studies, so I'll just brief it down. We are dealing with a case study of H&M online store, clothing store. In 2018, okay, Sabira Chaudhary, she published a report in the Wall Street Journal. She talked about H&M, and it is one of the big online clothing firms, and it started using data analytics and machine learning together. So this is how in real time people are using machine learning and data analytics together in clothing store. Like it is being used to detect trends. H&M is using blog post and the search items in the social media, the people they are the people that are searching H&M clothes. Okay, and they are using natural language processing for machine learning for analyzing all these things, and they are using quantitative analysis to make better decisions. So you can just analyze this, that whatever terms we have talked about, they are being used in the real scenario. Okay, then they have used the algorithms to analyze inputs, historical sales on products and every store. So they have different stores at different locations. So they are making predictions, okay, which store should be having how much stock. If the sales are more from that particular location, that particular store must be stocking more of that data, more of that product. So these kind of products, okay, if a particular location is ordering more and more of purses or more and more ladies bags, so that the location, the store location must have a good stock of purses. Another location, another store is having more demand of coats or say dresses, then it should have more stock of those dresses. So that kind of predictions and sales and everything that we have studied so far, the H&M company, if you carefully studied this case study, then you can just see that they are using predictions also, they are using analytics also, machine learning also, okay, and they're using natural language processing algorithms, they're using image recognitions and everything. And according to that, they are using algorithms for quoting the prices. Now they cannot quote any price by their own. Okay, it has to be having some basis from algorithms. So algorithms must be used to calculate prices based on the demand, based on their sales and everything. Okay, so this case study shows us, gives us a brief idea that yes, companies, okay, those companies which actually do not deal with technology, the brief idea was that yes, there are jobs for this, and companies that are actually not the technical companies themselves, they still use analytics, data sciences, business intelligence, machine learning, and all such technical people. They hire them for improving their businesses. So this gives you an idea that yes, there's a good scope for these kind of technologies ahead. Okay, now I come to the core part of machine learning. Now it's time to dig into machine learning further. Okay, somebody yesterday was talking about okay, machine learning data sets. So before we go with further machine learning algorithms and everything, it is important for us to know that where we can get data. Okay, what are the different repositories from where we can get data, and we can use that data for our research purpose, for our projects and everything. So you can utilize these 7 data sets. I've given you the 7 resources, the most used resources. So you can use Kaggle data sets, one of the good repositories, a huge repository of data. And Kaggle data sets are mainly used for data science and machine learning only. The data sets are of good quality, and you can incorporate many changes into them, and you can just drift your analysis accordingly. Then you have UCI machine repository, again a big repository is there. Again, if you want some real-time data, if you want corporate data for your research, you can go through Amazon Web Services datasets. They are also giving you open data. So you can just go through that. Again, Google is also having its own dataset search engine. Google is having dataset search engine incorporated into it. So you can just go through data search and Google's data search, and then you can find out the dataset. Okay, the Google's data search engine will not give you its own dataset. It's not a data repository itself. Rather, it will give you, different options from where you can get your required data sets. So Microsoft is again having its own data set. And I hope you must be knowing, but this is something new, that government data sets are also available to you. Previously, Indian government did not, out its data, but now because of Digital India and every data set is being available for research. So they have posted in on data.gov.in. On this website, you can get open source data set of the government. They basically are using that data from health sector, from agriculture sector, from crime sector. So if any one of you is developing projects on these kind of scenarios, then you can use your own country's data. You can just log into data.gov.in, and you can get Indian data sets. So they are using these data sets for research purpose. Okay, then again, for you, if you want to go Skykit also there. Scikit Learn is giving its datasets exclusively for machine learning. So you can just hop into this website, and you can get your datasets from here also. So these were some of the repositories that you can check in, and you can download datasets, and you can incorporate them into your own algorithm. So these are some of the widely used or popularly used datasets. Okay. Now, I have jotted down some points that there are different job roles in machine learning, data analysis, data sciences, and data analytics. So if you are trying to make your career in different domains of machine learning, data science, and data analytics, then these are a list of job profiles. I will not go into details of these job profiles today. I have kept this as the trump card for tomorrow. Okay, we'll check out the details of each and every job role tomorrow, because somebody asked me as a question. Somebody wanted to know what kind of jobs you can expect in this domain. So today in this session, I have just jolted down the points that yes, you can be a data scientist, analyst, data architect, data engineer, the statistician, database administrator, business analyst, and data and analytics manager, because somebody asked me this question. So I've just jolted down the points, but I have kept this as the trump card for tomorrow. So we'll exclusively talk about what should you study for a particular domain, for a particular position. Okay, if you're preparing for that, we'll just see it exclusively tomorrow, that what should be done, what skills should be acquired for this particular profile. So I'm just skipping this particular part. I've just jotted down the points. Okay, we'll talk about this in detail tomorrow. Okay. Now, coming back to the machine learning part again. So, best way to learn machine learning. Okay, somebody also asked me yesterday that what should we do to learn machine learning? What are the best ways? Okay, should we have firm knowledge of mathematics or statistics, or should I be good on programming? So, what should I do? What should be done to learn machine learning? So there are some steps that you can go through while learning machine learning. You can just see these steps. I have jotted down some 7 steps for you people. Just see the first step. Yes, mathematics is important, as I answered it yesterday also, that the part of mathematics that you should be dealing with is important, because you should be, very well versed with probability factors, with probability problems. You should be well versed with the problems of Gaussian algorithms and logarithm and everything. So we are going to use those parts in our mathematics, the mathematical components in our machine learning algorithm. So that part is very important. You have to study mathematics for that part. Okay, so another thing is that you should be having the mastery of statistical techniques. Okay, you should be very confident in defining mean average, maximum values, minimum values, the count part, the missing value handling. So statistical techniques and methods you should be well versed with. You should be having an idea of mean, standard deviation, variance, and everything. Because when you are dealing with data and you are dealing with quantitative approach, then the statistical techniques are very important. Okay, you should be having a fair idea about these techniques. Then machine learning algorithm, now comes the technical part. Okay, after your mathematics and statistical part, you should be having idea of machine learning algorithms. Okay, what classification is all about, what clustering is all about. I'll try to give you a brief up about these algorithms today. Okay, next, you should be expertise in programming languages. Now, machine learning algorithm gives you the algorithmic approach, the concept, okay, cluster and classification and everything. It will give you that part. But how to implement it must be through some programming. So that programming part comes from, learning Python or R programming. These two are the most popular machine learning algorithms based on. Like but let me make it very clear. These are not the only ones. Okay, these are the most popular ones. But yes, if you are Java people, you can go with machine learning in Java also. You can develop your machine learning solutions in Java also. But yes, definitely people don't prefer Java because it is hardcore coding and not very nice frameworks are available for machine learning. So for programming, yes, you must have R program. Okay. Then you must grasp the concept of data learning and analysis. So I just tried to give you that glimpse of analysis part also of data, what data analysis, analytics, and data sciences could be, so that you can relate with all the domains. Now, for this, you must refer to books and machine learning communities. You can see, guys. You can just see on GitHub and on other such repositories. You can see there are many problems. Machine learning problems are there. You can just on LinkedIn also you have many machine learning groups. So you can join in those groups. You can join in the hackathons of machine learning, and you can practice the problems. Okay, you can just try to find out the solutions for those problems. This will, whenever you will practice, no, if you are through with your machine learning course, if you already know complete machine learning course, algorithms and everything, then you must practice the solutions. Okay, this will help you to develop your solution making art. Then you should again practice your machine learning project. So that will be the sum up of how to learn machine learning. So machine learning could be learned in all these 7 ways. You can strengthen your mathematics, statistical parts, machine learning algorithms, data analysis, data analytics, Python. You should be knowing Python or R programming, whatever suits you, your requirements. Okay, you can go through them. You must go through some references and practice projects and solutions. So that would be, that would be all. That would be the best way to learn machine learning. Okay. Okay, guys. Now it's time to go about machine learning applications. What are applications you can see? Okay, where you can see machine learning and in specific domains, what algorithm of machine learning you should be using. So this is a very important question that needs to be answered, because machine learning has different number of algorithms attached to it. There are different kinds of technologies attached to it. So each and every technology has a specific purpose, and in that specific purpose, they are being used. Now, this infographic is going to give you a brief view of each and every application that you can have. Okay, so you can see here in machine learning, we have learned about 3 types of learnings: unsupervised, supervised, and reinforcement. So if we start with supervised learning, we have 2 further domains attached to it. We have classification domain and we have regression domain attached to it. So in classification domain, if you talk about classification, then specifically image recognition, image classification system. And if somebody also asked me the question that in banking sector, in credit card sector, how you can use machine learning. So here, my friend, here is the answer of your question, that you can use specifically classification algorithm of machine learning, classification solution for identifying frauds. Okay, you can identify and use the classification for fraud detection. Okay, again, you can use credit card fraud detection scheme also. You can use identity fraud detection scheme also. So that kind of detections could be done through classification. Now, again, in medical field, you can use detection of a diagnosis of a particular problem. So that kind of diagnosis, okay, diagnostics problems could be dealt again with classification. So these are just some, because classification has lot many uses. They have so many uses around the sphere. These are just the popular ones that I'm showing you. So identity fraud detection, whether it be image classification or whether you are trying to recognize voice, okay, whether it is customer retention or diagnostics, okay, these are used through classification. So another method of supervised learning is regression, okay. This is more of mathematical method of using supervised learning. So regression is basically used for prediction, okay. You are trying to predict in numerical format, okay, what could be lying in the future. I repeat again, through regression, you are trying to get or quantify numerically, you are trying to find out in numbers what could be there in future, what could be the prediction of the sales, what could be the prediction of rainfall, okay, this kind of prediction. Weather forecasting, if you talk about weather forecasting, our weather department uses this kind of problem. They uses these kind of algorithms, regression algorithms, to predict or to forecast that whether it may rain tomorrow or not, in which area it may rain. Okay, so market forecasting is there, like you can predict whether stock market will crash, whether stock will go up, whether the stocks will go down, what price quotation should be there. So all those analyses are being done through regression algorithms of supervised learning. Okay, advertising popularity prediction. Okay, like I gave you example for my product, for my company's product, if I want to hire this particular celebrity, then again, that kind of prediction, okay, what may happen if I associate this particular celebrity with me, what kind of obligations or what kind of points I have to follow. So that kind of predictions could be done again with regression. So population growth prediction, again, you might have heard in many reports that they may say that Indian population in next 10 years would reach to that and so benchmark. It will cross 150 billion trillion figure. So that kind of approach, that kind of prediction, again, you can get through regression, because regression is involving analysis of the past data, and it is using that analysis, and it is plotting that analysis and then trying to predict what may happen in future. We'll go through the regression in some time from now. We'll go through regression in details. Okay, then again, if we talk about unsupervised learning, because it is, you have had lots of data available to you, you do not know what you want to actually detect or you want to predict. So you are trying to discover, you're trying to explore. Unsupervised learning deals with the scenarios of exploring, कुछ नया निकालना चाहता है. Unsupervised learning हमेशा कोशिश करेगा कुछ नया निकालने की, क्योंकि आपके पास जो डेटा है उसका आप आउटकम नहीं प्रिडिक्ट कर सकते. As I repeat again, you cannot predict the output. The outcome is unknown. Okay, so unsupervised learning deals with the problems of the unknown. Okay, new data may come, and how to deal with new data, the strategy you have to make through unsupervised learning. So two major techniques that we use with unsupervised learning. One is clustering. As I repeated again and again, clustering makes the groups. Okay, you are trying to form clusters. You are trying to form clusters, groups out of the similarity based in them. देखो, जितने भी आपके पास डेटा ऐसा है जिसमें कुछ सिमिलैरिटी वैल्यू है, that data which is having similarity value will be grouped under one cluster. That is why it is known that intra-cluster similarity should be high. When I say intra-cluster similarity, that means कि एक ही cluster के जितने भी data points आप plot कर रहे हैं, all of them should be having similarity, high similarity index value. The similarity factor should be very high. While on the other hand, on the contrary, if you are talking about inter-cluster similarity, then that means that between two clusters, if you talk about, then those two clusters should be different from each other. They should not be having similarity values. They should be totally different from each other. So clustering is used for some of the applications like recommender systems. Whenever I talk about recommender systems, then your mind should be hopping towards clustering. Okay, if I'm trying to develop an application, suppose I talk about a real-time application. If I talk about Amazon, okay, you are trying to buy from Amazon. You are trying to buy your products from Amazon. Now you are watching some particular product. You are seeing some particular product. Suppose you want to buy an AC, okay, air conditioner. Now you are seeing the air conditioner of some company, say LG. You are seeing LG air conditioner. Now, along with that, in the below of the page, it will give you recommendations that in your budget, because it senses the recommendation system of Amazon is based on these things. Okay, it sees what kind of budget you have. It is not asking for your budget directly, but it is seeing that that kind of budget is shown through the pages you browse. Okay, you are trying to buy a window AC, or you're trying to buy a split AC. That shows from your history. You are trying to browse things. Okay, you are trying to browse this kind of budget. You are seeing the ACs of 30,000, 40,000 only. So it is recommending you the results based on what you browsed in your history. So that kind of recommendation system is provided through Amazon. Plus, along with that, the recommendation system of Amazon, because it has data of other users also, it is seeing what other users in the same product branch, in the same type of products, what are they seeing? Other users are also seeing the similar products. So now it is clustering, it is grouping you all. Okay, so according to that group, it is showing you recommendations from other customers also viewed this. So what is that? They have recommended you along with this. So recommended that through the history, the navigation history from other users, browsing history. So that kind of knowledge is being incorporated in your recommender systems. Fine. So anyways, Netflix is also using recommendation systems. Netflix is also using this system to recommend you what movies you should watch. Okay, it is showing you might also like to watch these kind of movies, these kind of online web series based on what you watched previously and what other people also liked to watch after they watched this particular kind of content. YouTube is also using such kind of recommendation system. If you watch, suppose say you watched a stand-up comedy of a particular comedian. If you watch, suppose say you watch the comedy show of Jivishu. Jivishu is a comedian, stand-up comedian. So what YouTube will do, it will start recommending you more and more videos of that particular comedian only. Along with that, it will start recommending you the similar comedians videos. Okay, the similar popular videos of all different comedians also, which other people also watched after watching the comedy videos of Jivishu. So these kind of recommendation systems are being used, and these are done through clustering. So you can make your projects, okay, ML projects based on clustering. And if you are incorporating a real-time recommendation system, you can recommend books, you can recommend products to the people, you can recommend what movies they should watch, you can recommend what should they read, where should they go for, where should they plan their holidays. Okay, so that kind of recommendation systems are totally using clustering part of machine learning. Okay, now targeted marketing is also there, customer segmentation is also there. You can just the most importantly, if you think about the big companies, they try to segment their customers into budget customers and other into spending high spending customers. So they have two categories of customers that companies see through. Or in fact, if I give you a brief overview in a little detail, then you can say that there are three kinds of customers that companies deal with. One are just free form customers. They are customers who are just freely seeing your website, they are navigating your website, and they are not in any intention to buy anything from your websites. They are free customers, like freelance people. They are free customers. So second one is the budget customers. Okay, they are going to buy, but they are going to buy in budget. They are not high spending customers. And third one is the high spending customers. Okay, they don't care about the money. They don't have any problem with the money factor. मनी की प्रॉब्लम नहीं है, सिर्फ अच्छा उन्हें अच्छे से अच्छा प्रोडक्ट चाहिए, नया से नया ब्रांड चाहिए. So obviously this kind of segmentation And according to that, recommendations will be given to them. That customer segmentation and recommendation, again, they can be clubbed together to create something, some project out of it, where according to the customer, next recommendation would be suggested to them. Again, targeted marketing could also be there. Another domain of unsupervised learning is dimensionality reduction. Now, this is very important because this dimensionality reduction is used in other research areas. They are used, for techniques like, if you want to compress your video, like you have a bigger video, you have a lecture of 10 hours or 12 hours with you, you have a bigger session. Now, if you want to upload it on YouTube, YouTube is having hell lots of space with it. But they, mind it, they are not going to upload your video as such. Okay, fine. They do not require you to do anything. Inside them, what they are trying to do, they are trying to compress that video content. They have their compression techniques, and they are trying to compress their your videos so that it could be easily uploaded and it could be used and watched easily. So they don't have any space crunch out with them. Similarly, we have big data visualization, because big data means, thousands of attributes attached. You have numerous attributes, you have multiple dimensions to watch for, and then you have to select, definite features or important features out of that, list of thousands of attributes. So that kind of big data visualization is also done through dimensionality reduction. So you have to just, check out only those important dimensions for your analysis. So that kind of things are incorporated in dimensionality reduction. Okay, the technologies used are principal component analysis, strategic analysis, feature reduction. Okay, now all this can be done through AI and through machine learning. Let me just make it very clear. This is automated process, and research are being done. If some of you are, if some of you are from research areas, so you might be heard of, dimensionality reduction through ant colony optimization, through techniques of machine learning. So these all, optimization techniques are being, used with big data, with the huge data sets, and these are being incorporated through artificial intelligence and machine learning algorithms also to automate the system. They are using neural networks for this. Okay, and they are using this for reducing the dimensions. Neural networks, they can incorporate their neural network, their perceptron networks, they can incorporate them. Okay, and they can train the machine to, grasp the important features out of the big, huge data set. So they can incorporate that. These algorithms are being worked on, and you can search these algorithms. You can read out different research articles given in these domains, okay, to elucidate more on this. Okay, fine. I hope you are getting some of the idea, okay, about this domain. I hope you are getting, आप लोग समझ पा रहे होंगे, आप लोगों को एक idea मिल रहा होगा. If you're getting the idea, you're understanding things, please keep on writing and giving your views. I just hope that I am making myself more clear to you. So just keep writing yes if you are understanding things. Okay. I'm trying to make it more and more clear with the help of, more and more real-time examples, because it will help you to get a glance of, okay, where it is being used, what the hell is machine learning, and why I need to study it. So that motivation part would come if you will see that, yes, around me only, this machine learning and data science and analytics and everything is going on around me. So that is why I have tried to give you, this kind of a visual where you can understand in real-time applications where you are using these algorithms. Fine. Okay. Now, I told you about regression. Okay, so let's just talk about regression more, because it is important, to dive into technical part also. Deep technical portion should also be there. So let us talk about regression. Like I said, there are two types of techniques with the supervised learning. The two techniques, classification and regression. Now, these two techniques deal with, different sorts of data. They are totally dealing with different sorts of data and in different sorts of domain. There is a complete bifurcation between regression and classification. Now, when you are dealing with regression, you are talking in terms of numbers. Let me make it very clear. If you are talking in terms of numbers, if you are talking in terms of predictions, you are dealing with regression on the basis of numbers and on the basis of their, what could be explored out of it. You are dealing with regression. And if you are dealing with categorical data, when I talk about categorical data, it means no numbers. It means it is the decision making process, whether I should go with decision A or I should go with decision B, whether I should categorize it in class A or I should categorize it in class B. Then that kind of decision making is done through classification domain. So these two are, different sorts of problems, and there are different sorts of solutions are available there. So a first solution that we're talking about is regression, where every time you are dealing with numerical values. So let us talk an example. Suppose we want to predict the cost of apples. Fine. Well, here we have to input, features. If I have a machine, a regression machine, where I will input some features of, say, a product, say apples, and I have to predict what kind of value it may have. I can train my machine with the data set because it's a supervised learning kind of a mechanism. So the training data set must have been there where it is already known that, okay, this is features. The cost of this apple would be, suppose, say, ₹5. Okay. Another kind of feature, if it's from Kinnaur, suppose Kinnaur is having very delicious apples, good quality apples. So let us keep it at a value of ₹10. If it is coming from Shimla, okay, then again it is having a cost of ₹8. If it is coming from Dehradun, for example, then it is having ₹5 as the cost value. This is based on location, okay, numerical values. Now you have some other factors also. Okay, if it is bright red, if it is having no spots, if it is having no black spots, if it is of good quality, if it is bigger in size, you have different features available with you. So you are training your machine on a numerical value. The outcome is going to be the value of the cost of that apple. Now, based on that data, you would be feeding in new test data. Okay, now you are giving, now you're not recognizing things. Now you are giving test data to your machine. You are giving some features. Okay, I have red color apple, this size of apple, these features, and it is coming from this location. Suggest me what kind of say cost should I put, what kind of cost suggestion should be there, prediction around that. So that kind of value, that kind of prediction comes under the category of regression. Now this is very important to understand. Then the cost may be changing again and again with your changing factors. You change the factor and the cost changes. The same factors, location Dehradun, the cost will change. The same factors, area Kinnaur, the value will change. So there is a linear relationship. You're understanding this particular thing. There is a linear relationship between the factors and the outcome. So when you're talking about the linear relationship, you are talking about a specific category of regression, that is linear regression. Let me show you linear regression also so that it will help you to understand it more in more details. Okay, so linear regression, as I told you, you change the factors, the cost changes. There is a linear relationship. So if there is a linear relationship, if I plot it, if I try to plot it, the kind of graph that I'm going to get is a linear graph. And guys, let me tell you, this particular graph that you are seeing here, you can plot through your data set and you can get that graph in Python through Matplotlib library you can use, and you can use your data set and you can plot this in Jupyter Notebook. Okay, we'll come with all these technical aspects after the discussion of these algorithms. I'll definitely come to your practical approach of what you should install and how you should go about it. So I'll just talk about that also. So anyways, you are seeing the linear relationship here. So linear regression here, if you are dealing with it, you are trying to determine the relationship between independent and dependent variables. So you have in regression, please remember this, in regression, you have two kinds of variables. Okay, the independent variable and the dependent variable. Now there, if I want to explain you it in a very simple language, very naive language, तो मैं आपको ये बताऊंगी कि ऐसे फीचर्स, ऐसे कह लीजिए एट्रीब्यूट्स जिनका एक दूसरे से जिनकी एग्जिस्टेंस एक दूसरे पे डिपेंडेंट नहीं है, उनको हम independent variables कहेंगे. I repeat, independent variables are those variables that have no relationship with each other for their existence. Okay, like suppose say if I say the particular feature and a location, that feature में अगर Apple की feature की बात करें, उसका bright red color, okay, ये Apple का ये जो feature है, that does not depend on the location. Location is another feature, whether it is the apple from Kinnaur or it is from Shimla. Both of them areas may produce red colored apples. So the color feature, the location feature, it might have some relationship, but not actual existence relationship. Logically, they don't have. Okay, they both are separate entities in their own. So the features which are totally different from each other. Suppose say another feature we'll talk about, weather forecasting department wants to predict today it may rain or not. So we have two different entities altogether. We have temperature that is going to be today and humidity content that is going to be today. Okay, logically they have their own independent existence. So that is why they both are independent variables or independent variables. Okay, the second category talks about the dependent variable. Now, what is going to be dependent variable? The dependent variable talks about कि उसका अपना existence depends on the other independent variables we talked about. Dependent variable is the one whose existence you can derive out of the independent variables you talked about. Like for example, मैंने भी आपको example दिया, weather department may forecast whether today it will rain or not. So rain is becoming the rain is becoming the dependent variable. It is depending on two independent variables, the temperature and the humidity content. So the dependent variable is the one who depends for its existence on other independent variables of temperature and humidity, as we talked about in rain example. Similarly, वो cost कितना होगा, जो हमने apples की बात करी, apples में हमने feature देखे, उसका size देखा, उसका color देखा, उसका location देखा. ये तीन अलग-अलग independent variables हैं, उसका size, उसका color और उसका location, इनकी अपनी existence है. Now the dependent variable is the cost. Okay, the cost is depending. Now you can understand the linear relationship. Okay, the cost is depending on these independent variables, the combination of these independent variables. I hope you are getting the brief idea of what regression is all about, and furthermore what linear regression is all about. I brief it up once more. Regression is dealing with numerical data. You are wanting to predict the numerical outcome, then you are going through regression. And usme bhi, in that also, if you are having a linear relationship, okay, no exponential relationship, no logarithmic relationship, no hi-fi things are there, it is just linear relationship of factors, then that kind of regression is linear regression. Okay, so graph here that I'm showing you is between the cars. Okay, we are talking about the two features of cars, miles per gallon, and it is mapped with the horsepower. Okay, so you are getting a linear relationship. You can also plot the same relationship for the example of, cost of apples. Okay, as you keep on changing the features, the cost will keep on changing too. Okay, now apart from regression, we have another very important machine learning technique, that is classification. As I told you, regression is totally different from classification. Regression deals with numeric output. The output is going to be numeric in nature. You are going to predict some value कि अभी एप्पल्स के ये फीचर्स हमने पढ़े तो उसका आउटपुट ये आ रहा था, नया एप्पल का क्वालिटी आया, उसका आपने फीचर्स डाले, इस पर्टिकुलर लोकेशन से आया, तो इसका प्रेडिक्ट करेगा कि क्या कॉस्ट रखा जा सकता है. इट मे टेक मीन ऑफ टू फीचर्स, इट मे टेक मीन ऑफ टू values altogether and then predict that values. So it depends on machine learning solution that you are providing. You may use regression. जो मैं आपको बता रही हूँ, these are all usabilities. These are all the basics. Okay, regression as the base लगा करके you can develop your own solution for this particular prediction problem of predicting cost of some product. Okay, you can use that. You can incorporate that. Now, for classification, if we talk about classification, अगर मैं इसको एक लाइन में एक्सप्लेन आपको करना चाहूँ, तो मैं ये बोलूंगी कि ये कैटेगरी बनाता है. ये आपको पता है कि भाई मेरे पास ये क्लास लेबल्स हैं, ओके, और मुझे ये कैटेगरी में इसको डालना है. जैसे अगर मैं कैटेगरी का एग्जांपल दूं कि if I talk about, okay, I have a bigger store, I am talking about a big mall kind of a scenario. There's a mall and it is having hell lots of different type of products. So it is going to classify, okay, all electronic products will go in wing A, all clothing products will go in wing B, and food and food court, everything is going to be in wing C. Now a new company approaches it. Okay, say Haldiram approaches it. Haldiram approaches it to set up its own store there. Now the machine learning algorithm will tell to classify, okay, whether it should go in wing A, whether it should go in wing B, and whether it should go in wing C, based on the Haldiram's products. Okay, now we know, we all of us know, Haldiram is not going to buy, Haldiram is not going to sell clothes, it is not going to sell electronic products, but yes, it is going to sell its own food products. So now it is going to be set up in wing C. So these kind of problems where classification is there, okay, where you already know the outcomes and you are there to categorize your incoming data. So that problems are dealt through classification. I hope guys, you are understanding things. I hope you all have got the brief idea of what regression is all about and what classification is all about. I hope I'm making it things clear to you. If it is clear to you, please keep on writing yes, keep on interacting, keep on jotting down the points for your queries, for your feedback, keep on typing in. It will actually help me to improve. You are helping me in a way to improve my lecture more. So keep on just giving your suggestions, keep on giving your feedback. It will help me out. Okay, so let us deal with the classification. Classification has different sort of algorithms also. Classification, in that we have, logistic regression, we have naive Bayesian algorithm, decision.
Madam, some are asking for some.
Sorry. Yes. Yes, sir. Hello. Yes, sir.
Yes. Hello.
Hello. Yes, sir.
Madam, some of them are asking for some practical input. Okay. So
Okay.
I think you have some demo for them, some inputs for them also. Correct. On Python, I suppose.
Yes, I should. Let me just particular topic. This is about to over.
Okay.
Yes, sir. Yes, sir.
Sorry for interrupting.
We'll talk about that also. No. Okay, sir.
And after that, we will go for question and answer round after that input.
Okay. Oh, fine, sir. Okay, guys, let me just wind up with this particular topic. Then I'll show you, then I'll give you a brief idea of how to go practically into it. Because see, guys, it's very difficult, to give you the conceptual idea and the practical idea thoroughly in limited time frame. Okay, it's really difficult, and I really ask for your apologies for this. That yes, I cannot go through with each and every component of theoretical and conceptual and practical part, but I'll make my best, try to give you a glimpse of each and everything, of how to go about, where to learn, and how to type in machine learning algorithms. So I'll just try to that. But before that, I'll just wind up with this particular topic. So we were talking about classification and different algorithms that are being followed in classification. There is logistic regression. There is, naive Bayesian. There is decision making, and there is support vector machines, and there is random forest, k nearest neighbors, and so on. Okay. Fine. Okay, I am getting some question also. Okay. Fine. Okay. Fine. Okay, I'll move to the question answers in a moment. Okay. I had some data for you for classification also. I'll just take it very quickly. This is the graphic you can see on your screen is about decision tree based classification. As the name suggests, in the tree format, if you are moving from the root and you are going to further, you are based on each and every question, each and every criteria, you are trying to classify things. Okay, I'll try to explain the example. Like you have the decision of whether a person is fit or unfit. With that, you can recognize if age is less than 30, that's yes. So we are going to the left subtree and we are trying another criteria. If he eats a lot of pizzas, then yes, again, he's unfit. If age is less than 30 and if he does not eat lots of pizza, then we may categorize it into fit category. So here we have two categories. We have fit category, and we have unfit category, and we are trying to categorize, the given data sets according to these particular criteria into two categories of fit and unfit. So this way decision tree works. I'll take it very quickly because we need to go to the practical demonstration also. So this was all about decision tree. Then we have logistic regression also. So one part of regression that we talked about was linear regression, and another one is logistic regression. Actually, the name comes from like, here we are not talking about the linear relationship, rather we are talking about the logarithmic function, logarithmic curves, and logarithmic exponential relationships we are talking about. So these kind of things where predictions, you have some data, and prediction has to be based on binary inputs. You have categorical data, but you are trying to predict in yes or no. You are trying to predict in binary form, 0 or 1, to make your predictions. Fine. So that kind of problems you deal with logistic regression, where you are trying to binary classify your data points. Like I gave you an example of we have three data points available with us. One is temperature, one is humidity, and one is rain. So based on the temperature and humidity content, we are trying to predict whether it will rain or not. Now, all these are having some numerical values. The temperature is having some numeric value, the humidity is having some numeric value, and the ultimate answer is to predict, yes, whether it is going to rain or it is going not to rain. So it is based on your logistic regression. Okay, what you are going to do, you are going to see the likelihood of the event based on your hypothesis. You are trying to draw your hypothesis. I'm sorry, I'm not going into details of this. I'm just going to give you a brief idea of this. Just listen to it carefully and try to understand that you will try to frame your hypothesis, and try to frame your hypothesis along with logarithmic function. You'll try to fit it into logarithmic function, okay, based on the plottings and the curves and mathematical, hell lot of mathematical calculations. You can predict in numeric form whether yes or no, 0 or 1 form. If binary form, I say the output will be 0 or 1, whether it will today rain or not rain, based on your plottings and based on the sigmoid part that you are going to calculate. Okay, you can see here I have tried to show you some mathematical calculation. Because of the time constraints, I cannot go into deeper details of this. So just excuse me for that particular part. We'll take up that mathematical details sometime in future. Okay, today because of constraints, I won't be able to take it up. But you can see logistic function that your graph may use is 1 upon 1 plus e raised to the power raised to minus x. Okay, so e here is exponential component, and which is going to predict the value between 0 and 1. And according to that, when you will plot it, you are going to get a sigmoid curve. Okay, there is a further logistic regression component also. Okay, this complete equation, if you see this will give you the idea of logistic regression. If you see this particular equation gives you the idea of logistic regression. E raised to the power b naught plus b1 into x upon 1 plus e raised to the power b naught plus b1 into x. Now these two are input coefficients. Okay, whatever input coefficients you will get, like temperature value, rainfall value, these are input coefficients that you derive from your inputs. And then you are going to use likelihood estimations. What likelihood is there? So that will come in the range between 0 and 1, and more towards 1, it will give you more prediction that yes, it is more likely to come to rain, more likely for the rain to come. And if it is near to 0 in points, then it means that it is less likely to come. So I'll not go into further details of this. I'll rest this topic, okay, for further discussion sometime in future, where we can talk in more details with numeric and everything. Right? Okay. Now, the next was about unsupervised clustering. There was clustering. So the most popular algorithms that you can use for clustering are k-means, db-scan, and hierarchical clustering. K-means clustering, I'll show you the demo. We can show that on Veka, one of the most popular, one of the popular machine learning tools for research. It is Veka. Another thing, we can use it with Python. So I'll try to show you the demo of both. So K-means clustering allows you to partition your observations into K number of clusters. The K here stands for the number of clusters. You can, find out the mean of the distance between a new point, a test point, and your previously plotted point. You can find out the distance, and if that distance is within that threshold, you can enter that new value into the previously plotted cluster. So it basically is talking about the entry of that point into that cluster based on some threshold value, some mean value, distance value. So if in case you want to study it more, you can just talk about K-means cluster in details. You can study about Euclidean distances. There are several sorts of distances. There are Euclidean distances, Manhattan distance, then Minkowski distance, Chebyshev distance. Okay, there are hell lots of distances through which K-means clustering can be developed. Fine. DB scan algorithm, density-based scanning is also there. Hierarchical clustering is there. If possible, I'll show you some visual for this. This was all about K-means clustering. In the demonstration, you can just see that you have before K-means clustering, you have just points plotted here, and after K-means clustering, you can see here, you can have different sorted clusters. Here you can see 3 clusters, 3 groups, red points together, blue points together, and green points together. So these were your clustering points through K-means clustering. So we have got 3 clusters out of it. So what I do now is that I show you this K-means clustering in a tool known as Veka. I'll try to give you a glimpse of 2 tools. First of all, I'll help you out with Veka, okay, one of the machine learning tools. And secondly, I'll try to give you a demo on Python, on Jupyter Notebook. So, okay, so for that, if you want to go through it, you must be having 2 tools. One is Veka and another is Jupyter Notebook that you should be downloading through an account. I'll show you some slides for now. We can discuss more of this tomorrow in tomorrow's session. I'll move on to the practical part. Okay, this is important to know that there are machine learning tools. These are the machine learning tools, the practical part that you should be knowing in future. These parts you should be able to understand. Machine learning languages, if you want to understand, then there should be Python and R. Either of them you can learn, okay? Either you can go through Python if you want to develop your own tools, okay? So if you want to analyze things, then that is a separate part. If you want to learn these things, then machine learning programming languages are 2, Python and R. Then you have certain tools also, TensorFlow and scikit-learn, Veka. As I'm telling you, Veka is open source, you can get it. Then there are different libraries of Python that you can utilize. NumPy, SciPy, Pandas, all these are Python libraries and frameworks that you can use. Then we have deep learning tools also. We have deep learning, we'll talk about tomorrow, but the tools that you can use, okay, through Python, you can use PyTorch, and Keras is also there for deep learning, okay, neural networks and all, you can go through that. And analytical tools, if you want to utilize in machine learning, then those are Spark and Hadoop, okay, 2 sort of tools we have. Then visualization tools, Jupyter Notebook, that I'll show you in a brief time from now. Seaborn, Matplotlib. Matplotlib is, again, you can use a separate tool also. You can Matplotlib through a library also. You can import that library in Python program, and then you can go through this, okay? So you can import Matplotlib library and plot your outputs. So that, because without bar charts, without histograms, without plots, it is very possible, it is very impossible to, through numeric value only understand what your data is saying. So you need to have visualization part. So I'll go through that part also. In the slides, we'll share the slides with you. I'll share the slides with everybody. So in these slides, I have given a brief intro to Python also. If some of you are not having any idea on Python, then you can go through Python also. Then I have given the features of Python, how to install Python, the complete installation process we have also, kept here. So installing part is also there. There are some installation steps. This is the current, the latest version that is available. Okay, I took this snapshot this afternoon. So 3.8.0, I am using 3.8.0 version. So you can also download it and you can use. Basically, Python is having two complete versions, version 2 and version 3. Okay, I deal with the Python 3. I'm more, liking Python 3 because it has improved features. It is very nice frameworks are included with Python 3. Python 2 was used earlier, but now most of the people are shifting towards Python 3. So when you download, just see to this that you are working with Python 3 also. But yes, ultimately it's your choice. If you want to go with Python 2, with some changes in the syntax, you can work with it. Okay, now there are some IDEs that we need to know. Okay, if you are trying to use Python for machine learning, there are some IDEs that you should be working with. One of the most popular and my favorite ones are PyCharm, Spider IDE. Both of them are, very good. Another Jupyter notebook you can use. Furthermore, we have another IDEs also where Python, not for machine learning, but as such, you can learn Python from these sources. PyDev, Atom, Wing, Thorny, Rodeo, Microsoft Visual Studio, again, it is also incorporating Python, Eric. So all these are different IDEs that you can use for Python. My favorite ones for machine learning are PyCharm and Jupyter Notebook plus Spider. These three are being used. PyCharm is not for visualization. You should not use PyCharm for visualization. If you want to just practice on console, if you want to practice some data on console, then that could be done through PyCharm. You can do it PyCharm. Console programming, PyCharm is good for that. But if you want to go for visualization, if you are using good frameworks, you are using NumPy, you are using Pandas, SciPy, Matplotlib, then you must incorporate Spider and Jupyter Notebook. Now, अभी ये सब कुछ देख के I think कोई भी ये सोचेगा कि पता नहीं कितना installation मुझे करना पड़ेगा, कितना Python मुझे install करना होगा. So no problems with that, okay? Because Python has made lives easy. It is a lifesaver. That is why I like Python. Because it has made your life easy for everything. And that is through Anaconda framework. If anybody of you has any of Anaconda framework, okay, you can type in in the chat box if anybody of you has any idea of Anaconda, Miniconda. Okay. Okay. Fine. I think it's new for people. Okay. Anaconda and Miniconda. These are some of the versions, some of the new versions that are bundles of softwares. Okay. Like अभी मैंने आपको जैसे बोला कि बहुत मुश्किल लगता है. अभी देखिए आपके Python environment आपको दिख रहा है machine learning का, NumPy है, SciPy, Matplotlib, Scikit-learn, Pandas, इंटरेक्टिव कंप्यूटिंग है. अभी हर चीज का अपना एक अलग मोटिव है, अपना एक अलग काम है. NumPy बेसिकली डील्स विद एरेज, मैट्रिसेस. ओके, आप डेटा क्यूब, इसका जो आइकन है वो भी डेटा क्यूब है. दैट मींस इट इज डीलिंग विद 3D डेटा, मैट्रिसेस. ओके, मैथमेटिकल पार्ट. SciPy is mostly about scientific Python. It is again dealing with scientific approaches. Matplotlib is all about visualization. It is dealing with graphs and chart. Pandas is together integrated with NumPy and SciPy, and it is being incorporated in Scikit-learn. Scikit-learn kit है, okay, it is a scientific kit for learning machine learning and Python. तो Scikit-learn में आपको ये सब कुछ मिल रहा है. Pandas भी मिल रहा है, NumPy मिल रहा है, SciPy मिल रहा है. लेकिन अभी मेरे को सबसे बड़ा जो क्वेश्चन आता है हमारे दिमाग में वो ये आता है कि इतना इंस्टॉलेशन करें कैसे, इतना सारा इंस्टॉलेशन. सो उसका सोल्यूशन है that instead of installing each and every of these libraries, of these frameworks, what you can do, you can directly go to Anaconda Navigator. Okay, this visual you can see on your screens. This is all about Anaconda Navigator. अभी आप अपनी स्क्रीन पे ही देखो, इस एक navigator में it's a bundle of software. It's not a single software, it's a bundle. Okay, Anaconda is a bundle. So bundle you are having PyCharm also integrated, then you are having .exe prompt, then you are having Lewis, Jupyter Lab Notebook, then you are having Orange, then RStudio, Spider. मतलब जितने भी अच्छे अच्छे आपके आईडीज हो सकते हैं जिनमें आप पाइथन को या आर को यूज करना चाहो, अगर आपको आर यूज करना है तो सबसे बेस्ट जो वाइडली यूज होता है दैट इज आर स्टूडियो. तो आर स्टूडियो इज बीइंग यूज्ड हियर. Now, if you want to use PyCharm for Python, if you want to use Jupyter Notebook again for Python, you can do it. You just need to install a single environment, that is Anaconda Navigator, bundle of software. So that is why the name given to it is Anaconda Navigator environment. This is a complete environment, and this environment gives you the navigation to all these IDEs. Okay. आर अगर आप आर प्रोग्रामिंग के थ्रू करना चाहते हैं तो उसके लिए भी बहुत अच्छी अच्छी आईडीज हैं, लेकिन एनाकोंडा में आपको जो मिल रही है दैट इज आर स्टूडियो. अगेन इसके अलावा भी बहुत सारी हैं, यू कैन जस्ट गूगल इन एंड गेट अ ग्लिम्प्स ऑफ दैट. बट एज फार एज पाइथन इज कंसर्न्ड, द एनाकोंडा और मिनीकोंडा, ओके, एक और टर्म मैंने लिया था नाम जिसका था मिनीकोंडा. सो मिनीकोंडा, this is particularly being used to directly install only those packages that we need to know. Okay, अभी ऐसा होता है कई बार, I don't need all the packages. ये Anaconda by default is giving you all the packages. It is giving you PyCharm also and Jupyter Notebook also and everything also. And along with that, you can directly import your libraries. आप जितनी library frameworks आपको Python में available हो सकते हैं XYZ, all of them you can directly import through this Anaconda environment. But Miniconda is a mini version of Anaconda. It helps you to install only those particular packages that you require to. Okay, guys, I'm just taking a minute break. Okay, till then you can just give your feedback and we'll just have a look on Veka and this Anaconda. I'm just taking a minute break. Okay.
हाँ मैं कर दूंगा. हेलो.
Hello, sir.
Yes,
Hello.
madam. Is it done or continue?
Sir, I've taken just a minute break. I'm just having water. Just a minute break.
Please.
Yeah. Okay. Yes, guys. Guys, shall we take the questions? Shall we take the questions and wrap it up? And we can continue further. Sir, can we take the questions?
Yes, madam. Please feel free to go for. Okay. And madam, some of them are asking that okay, from where the content is taken from online. Okay, so they
Yes.
want the credit to be given. Okay.
Okay. Right.
Yes. So please let us everyone know that okay, from where the
I think we
images
will.
are used, because
Yes, we can put them in references. I think at the last we can put them in references.
Okay, madam.
The websites and the areas. So that
Sure.
will be.
Yeah, but kindly put that. Okay, and you can see the questions from your YouTube section, YouTube chat.
Yes. Okay, guys. I am taking the session's questionnaire now. Okay, if you have any of the questions, please let me know. Okay. Okay, I'm taking the questions. Okay. Natasha Nair. Okay. She is telling. Okay, ma'am. We'll put the credits section. We'll definitely put up the references and from the website and from the area where they are taken, because this is an open session and the content is taken from the open space. So definitely, ma'am, we are going to put up the references and we'll definitely give the credit to each and every space from where the content is being taken, because I took up the best content to explain it in a best way to my audience. So I'll definitely put up that contents credit section at the end. Okay, references will be put at the end. So I think that would be okay, Natasha ma'am. Okay. Punamala Bhagyalakshmi. Okay, she is asking, can you send us some video for learning Python software? Okay. Thank you for asking this question, Punamala. Actually, see, videos you can just enroll with the Squad Online, and there you can have the complete course of machine learning and data science, because that would be good. If you have live sessions, you have a live teacher, and he's taking up your problems and he's explaining you the contents in the best possible way. So I think that is going to be in a good approach. So you can just check in with Squad. Plus, along with that, if you want to go for online content, then yes, videos definitely are available. Good videos are available on YouTube. You can search it out and you can Google it out. Good videos are available to you. Okay, but ultimately depends on your level of understanding. Okay, if you are getting what the teller is trying to teach you, what the trainer is trying to teach you, okay, if you're understanding that frequency is matching, then you can go on with that particular video content. Other video contents are also there. You can enroll with Squad also. One option is this. Another ones are Udemy, Udacity, Coursera. There are so many other contents available. So you can just check out with that. Right? Okay. I hope Punamala, that will be okay. Fine. Okay, let me take other questions also. Okay, Swarna ma'am has given a suggestion. She said that one suggestion in tomorrow's lecture, instead of theory, please give some practical demo. Okay, Swarna ma'am, well taken. I'll definitely give some practical demonstration because of time constraints. Before giving any practical demonstration to the audience, it's necessary to tell them what I'm going to tell. Like today, I have given them a brief intro on about what is classification and what is clustering, what are algorithms are there. So it would be easy for me to give them a glimpse on Veka or on Jupyter, so that I can take a data set and then show them what classification we are doing, what clustering output they are seeing, because many of them may be naive. Okay, they may not be having any idea of these things. So that is why it was necessary to take up the theory part. But yes, a very nice suggestion. I'll definitely incorporate practical part in tomorrow's lecture. So thank you so much for the suggestion, ma'am. Okay, then we have okay, Resham. This is to appreciate that Nidhi ma'am has okay, in-depth knowledge of machine learning. Thank you so much. Thank you. I'll take it as a very nice compliment. Okay, thanks for all compliments that you people are giving in. I'm really overwhelmed by your compliments and your feedback. Okay, Shraddha. Shraddha is asking another question that, ma'am, in PyCharm, which libraries are required to install? Okay, very well. Shraddha, yes, I'll show you content for this. Okay, these are some of the libraries that you can use for machine learning. Okay, NumPy, SkyPy, Pandas, Seaborn, Matplotlib, all these are libraries. But one thing, Shraddha, I want to suggest you that if you are are working on machine learning specifically, and if you want to go for visualization, because without plotting, the only numbers are not going to serve the purpose. Okay, every algorithm you implement should be having some plots associated with them. So for that, I suggest you to go for, you know, Jupyter or Spider IDE. Okay, you can, as I show you in Anaconda, you can just launch Spider or Jupyter, and there you can import these libraries automatically. Okay, in the import section you can just import these, and then you can go for visualization, because in PyCharm you cannot see the, you know, in a very good detail the plots and everything. So plots in a very good quality, in a very fine quality, you can see in Spider and in Jupyter. So you can use those for machine learning plotting. So this was my suggestion to you, and these are the list of libraries that you are seeing on your screen that you need to install. Okay. Now, fine. Okay, Shreyas is saying we can also use Google Colab for machine learning. Yes, of course, Google Colab is easy and it can be used. Fine. It is also one of the options for learning machine learning. See, Google is, I would say, the master of machine learning. Google is using machine learning everywhere, whether it is Google, you know, it is Google Assistant, whether it is Google Map API, whether Google is using any chatbot, it is giving you search results, everything, whatever Google is using is doing with the help of machine learning. So yes, you can use Google products also for learning machine learning. And okay, Shraddha is asking, CNN and ANN classification techniques deal with machine learning or not? Okay, ma'am, convolutional neural networks, and obviously if I say completely neural networks, yes, they do work. And specifically, if I talk about, then they work with the reinforcement machine learning. Okay, reinforcement part, because they deal with, you know, AI. They deal with creating such kind of networks which can take decisions. Fine. So they are being implemented in chatbots and some neural network application areas. So machine learning, and specifically reinforcement machine learning, is using, okay, AI and these ANN and CNN techniques. I hope that would be you know, satisfactory answer, because it is a complete separate domain. We won't go into much details there, but yes, I can suggest you this. You can read about reinforcement learning and AI more, because they both together are used along with ANN and CNN. Okay, product specifically. Okay. Srimati Narayan, she is asking, for academic purpose, which is preferred, Anaconda or Miniconda? Okay, ma'am. Okay, Srimati Narayan, thank you for asking this question. Academic purpose, if you ask me academic purpose, then I won't say that either of them is good or bad. Both have their usage, because this is not dependent on purpose. Okay, academic purpose is not the answer to it. It depends on what task you have. If you are very proficient and you know your requirements, you know what kind of packages you need, then you can go for Miniconda. But yes, if in case you are in the learning phase and you want to check out different options available, and then you know, you are not very sure about the task, okay, that you may require, then you can go for Anaconda. And one thing I want to add on to it too is that Anaconda is a full version environment. Miniconda is the mini version of this environment. So you have to be very clear with what you want. Okay, which packages you want to install separately, manually. Then only you should go for Miniconda. Else you can go for Anaconda. Okay, Smitha Reni, she is asking. Okay, she is telling. Okay, thank you, ma'am, for appreciating, for your appreciations. Thank you. She said that she has a suggestion to prepare a schedule for the lecture and try to follow that. Ma'am, we definitely try to follow that. You know, in a professional zone, it's very important to be very, you know, through with the session and through with the timetable to follow. But yes, in such a, you know, public domain where so many queries are coming in, and different domain people are there, it's very difficult for me to, you know, keep up with the session, because I have to maintain the pace also, I have to see the time constraints also. So I try my best, and in further future, I'll try more to stick with my timetable. Okay, but with my audience, I generally, forget the timetables. I'm sorry for that. Anyways, uh, okay, Meenal, you are asking for SVM. Okay. Meenal, I'll skip this topic for today because really this is a very time, taking topic. I don't want to, go with it like anything. It is a very, very important one, and I think it's not a part of this particular session. We can discuss this topic SVM in great details in depth sometime afterwards. We can keep a separate session on SVM. Okay, because simple vector machines are, क्या बोलते हैं उसको, जान of machine learning. अभी बहुत use होता है, but I'll not go through this because it is, I really have time constraints with me. Anyways, okay. Some user SHN21 saying, can we get a soft copy of today's PPT? Yes, through Squad you can definitely get the copy. Okay. Okay. Kiran, good morning. Kiran is asking, ma'am, in Anaconda, can we use Spider and Jupyter? Okay, what should we prefer? Okay, fine. See, both, I have used both, and I don't know which one to prefer. It depends on my, say, my purpose. Like, if I want to go with the, some of the plotting and more of the usage of libraries. If I want to use all the libraries, NumPy, SciPy, and I want to, implement the algorithm in a beautiful way, then I prefer to go with Jupyter. But in case I want my plottings of the data to be of very fine quality, very best quality, then I go for Spider. Both of them are, good IDs, and both of them give you the chance to explore more. But one thing Spider is having the benefit that you can set your directories, and you can see what all files and data you are using in the file explorer window. There is a small window, file explorer. You can just see all the directories and everything, and it's very beautifully created to give you a glimpse. Okay, which data you are using, data set kahan pe hai आपका Python file kahan pe hai, आप कहाँ सेव कर रहे हैं. That directory structure is very beautifully engrossed with that. So I think Spider is good if your requirement is such that if you are doing very integrated work, lots of files are there, and you want beautiful plots out of your algorithms, then you may go for Spider. Okay, otherwise Jupyter is also good. You can just try your hands and create your own preferences. That would be really nice if you can do so. Okay. Okay, Ash is asking which is better, Python or Arduino with C for hardware. Okay, hardware. Okay, fine. See, they have their own applications, so you can go with Arduino if you want to, create some IoT devices. You can hardcore in C, because some of the people have worked beautifully with the C language and on Arduino to create, intelligent small devices, IoT-based devices. I would say it's easy to, link it with your phone, smart devices you can create. So you can work with that. And IoT with Python. Okay, see, what I have seen in recent times is that people are more and more using, Arduino with C for hardcore physical device programming. Okay, but Python are mostly using, people are using when they want to integrate their websites and their web applications, or their, those kind of applications that are already pre-developed in Python or in some other web languages, and they want to integrate with it with IoT, then they're going with Python. Okay, so they both have, different usabilities as far as my knowledge says. Right? You can just search it out more on that. So it depends only the product that you are going to develop. Okay, if it's something physical product, if it's a device that you want to program, then you can go with Arduino and C. And if you want a web application to be integrated, integrated with IoT, then you can go for Python. So this is my version of answer. You can just learn more about it. Okay. Okay, Ankur is saying, can you provide data set to work with? Ankur, I have already discussed many data set repositories. Okay, you can go with UCI repository, Kaggle repository. All of them are open source. You can just directly, in fact, UCI is a huge repository. You can get a lot of data sets from there. Data.gov.in, government resources are also there. You can just take data set. For research purpose, if you want to just demonstration and research purpose, you can IRIS, IRIS, iris.csv, and wine data sets are also there. Wine, 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 red wine and white wine data sets are also there. You can just download them and work with your data sets. Okay. Okay. Altaf Ansari is asking, on working with machine learning, it is also necessary to learn deep learning. Okay. See, Altaf, they are both, related but yet separate domains. दोनों साथ में काम कर सकती हैं, but हैं दोनों अलग अलग. So machine learning, if you want to learn machine learning, it's not actually necessary to go with deep learning. But yes, you can learn deep learning also. It's you can say AI or machine learning के साथ का एक part है. It's a colleague of these two domains. So we'll talk about deep learning tomorrow. Okay, in deep we'll get some idea about deep learning also. So, but yes, it's not necessary to go with deep learning if you want to go with machine learning. Okay, robot is, okay, Sneha is asking, robot is which type of machine learning? My dear Sneha, robot is not a type of machine learning. Robot is an AI device, okay? Robot you have created using artificial intelligence, and in that robot, you are using some kind of learning procedure, okay? That learning procedure, either you are using reinforcement or you are using, if that robot is a device, if it is using if it's a human device, artificial human kind of a humanoid kind of a structure, then you can go for reinforcement. If it's some kind of a medical related device, medical application, okay, then you can go with supervised or unsupervised. So it depends. Machine learning is the learning part incorporated into AI device. Okay, anyways, Shraddha is asking, can you provide PPT? Yes, ma'am, you can get the PPT from Squad. Okay. Fine. Okay. I hope that's all. Most of you have asked your question, and I have answered, I've tried to answer most of the queries. Okay. If any of the queries are further left, you can just type in, you can just type in the chat box, and we can take it up tomorrow, because tomorrow also we have the concluding session. Okay, tomorrow I'll try to give you a hands-on on Jupyter and on Veka also, because for research purpose, you can use Veka, and for learning purpose, you can advanced, you can go for Jupyter. So I'll give you a glimpse of both of them. We'll try to see clustering classification on Veka, and we'll try to frame a Python program on, a small, I'll show you a plot and everything on Jupyter. So now it's time to wrap up. So can we wrap up for the day?
Yes, madam, of course. And as per the request that we need to give the credit to the respective
Yes.
websites or the people, like I think from some of the content have been taken from the LR Tiwari College also. Okay, or as the question has been asked from the Natasha ji. Okay.
Yes, yes.
So I would request you, okay, to credit to all the respective websites. Okay, so anyways, because it's a intense training for the college faculties, FDP program, faculty development program for the colleges. Okay, so we tried our level best to gather the information online in the smallest amount of time which was available. Okay, so we will try our level best to give the credit. Okay, but if we know by chance or by mistake, if we ignore anyone, please update us. We will update our PPTs or description, video description accordingly. Okay, as the intention
Sure.
give everyone the in-depth knowledge. Okay, so that students should get benefited from the lecturer's knowledge. Okay, so that was the whole sole intention. And as today's session we are ending, and tomorrow we would be having the last session. Kindly keep your questions ready for tomorrow. Okay, So I am thankful to all the participants, okay, for asking question. If any question is unanswered, okay, we are sorry. Please note it down. Okay, we would be answering. We will be having a bigger or better question answer round tomorrow. Okay. So thank you, madam. Okay, so we will continue tomorrow. Okay. So tomorrow's timing is again 3 o'clock. Okay. Thank you. Thank you very much.
Thank you, sir. Thank you. Okay, guys. Bye, everyone. Bye.